we've looked at all the firm's costs, and we've looked at firm's revenues in a previous video. Now let's look at them together. So the first thing I'm going to do is draw a line that represents the firm's revenue. And I'm just going to do a straight line here, and this will be the firm's revenue. Now, as you remember from the last video, we have a perfectly elastic demand curve. So when the demand curve is perfectly elastic, certain things are all equal to each other. So we have marginal revenue, price, average revenue, and demand are all the same. So I write out that curve, we'll call it Mr. Party. And that's because every unit is sold for the exact same price. So we have price and demand on there for that regard. Now, if you sell every single unit for $5, then the average price or the average revenue you're going to get per unit is going to be $5. And if you're selling every unit for $5 and you sell one more, then that additional revenue that you're going to get is also $5. So that's why these are all equal to each other. Now, faced with the various costs and its revenue, the firm has to decide what quantity of units it's going to produce, and then it also needs to know how much profit it's going to make. And we look at this curve or this graph in order to understand that. Now, the first rule, and this is the most important rule in microeconomics, is that the firm should produce every unit so long as the marginal revenue is greater than the marginal cost, or another way of saying it is that the firm is going to produce every unit up to the point where the MR equal the MC. Now let's look at exactly what that means on this graph. Here's the marginal cost curve, and here's the marginal revenue curve. We should produce a unit as long as the additional revenue received from that unit will be greater than the additional cost. And as you can see, for all of these units, that's the case. So anytime we produce a unit where the marginal revenue is greater than the marginal cost, that allows us to add to our total profit. Let's take a couple of minutes to elaborate on that concept of firms maximizing profit at the quantity where MR equal MC. I've drawn two graphs here. The bottom graph you should recognize from the previous section where we just looked at marginal costs and marginal revenue. And the top graph we're going to talk about in just a second. It's basically your total product or total profit graph. Now we're going to look at in this case, and as we mentioned before, it's that the firm wants to produce units as long as the marginal revenue is greater than the marginal cost. And as we said before, we find that to be the case all along this area. And then eventually we reach a point where marginal revenue equals marginal cost. Now, for all of these preceding units, all of these areas where I've drawn the green dots and the dotted lines, what we can say is that the additional revenue the firm receives for producing and selling that unit is greater than the additional costs that they incur by making that unit. And if that's the case, then that unit adds to their total profit. It doesn't necessarily mean they're making a profit. It just means that producing that unit would either add to profit or subtract from any loss that they might also be incurring. So as we produce these units, and we'll assume that they are making a profit, total profit starts to rise. So all along the area where the marginal revenue is greater than the marginal cost, and that's this area of the graph, total profit is increasing. Now we reach a point where MR equal MC. That unit really, the firm neither adds to or subtracts from profit. From that point forward, though, if they go ahead and try to produce this unit past the profit maximizing quantity, for that unit, the marginal cost is going to be greater than the marginal revenue received. So that unit would subtract from profit. And that would be the case for all of the units in this area of the graph, because the cost is greater than the benefit for all of these. If the firm went on and continued producing past the point of the profit maximizing quantity, they would find that their profits would start decreasing. Their profits would decrease because they were producing units whose costs they were producing units where the benefits did not justify the costs incurred. So going back to again, we see at that one quantity, the quantity where MR equal MC, on this graph we know that on a graph of total profit, the firm is maximized. And they've maximized their profits because they've produced all of the profitable units, but they stopped and didn't go ahead and produce any of the units that did not maximize profits or did not justify their cost. Once the firm has determined which quantity will maximize profits, it then calculates how much profit it's going to make by producing that quantity. The formula for profit is equal to total revenue minus total cost. The problem that we run into is that our graph doesn't have total revenue and total cost on it. It has all average revenues and costs and so on. So we need to do a little algebra here to convert this into a formula or a format that we can work with when we use our graphs. So let's just take a look at how this equation that we're looking at here breaks down. As you know from class, total revenue is equal to price times quantity. And total cost is equal to average total cost times the quantity. Now where did I get that from? Well, as you may recall, we did the triangle where we looked at T, A, Q. And whenever you're looking for something or whenever you want to find one of these, you cover that item up and then it tells you what to do mathematically with the other two variables. So if we're looking for total cost, then we're just going to color in the total here, and we have A and Q next to each other. And as you know from algebra, when two letters are next to each other, two variables are next to each other directly like that, we multiply them. So from this, we know that we need to find total cost, we need to take average total cost times the quantity. So now we're left with profit equaling price times quantity minus average total cost times quantity. And all we have to do at that point is factor out a Q, and we're left with price minus average. Let's think about this for a minute, because it should make rational sense about what we're actually looking at. The price is what we're selling the unit for, and we're selling every unit for the same price. So price is the same thing also as saying average revenue in this case. So it doesn't matter which one we use, I'm going to use price. So on average, how much are we selling them for? And if we subtract from that, on average, how much it costs us to make one, that gives us our profit per unit. So this whole part of the equation here is profit per unit. And incidentally, every time you see per unit, that tells you that you're dealing with averages. So this is our profit per unit. Our total profit is going to be equal to the number of units we sell multiplied by that profit per unit. So in order to find total profit, we just take our profit per unit and we multiply it by the number of units sold. So to restate, profit, as well as being equal to total revenue minus total cost, which is what we have up here, is also equal to the quantity times price minus average total cost. Now that we've looked at how firms determine the profit maximizing quantity and how they use that quantity to determine what their profits will actually be, we can go on to show those profits on a graph. So we said rule number one, we're going to produce where MR equal MC. So automatically we know that if this firm were real, they would be producing this quantity because that's the quantity where MR equal MC. We'll just make a quick adjustment to that, and we see right here MR equal MC, this is the quantity the firm would produce. Our second rule was that profit is equal to price minus average total cost. Well, price is found on the marginal revenue curve, and then here is average total cost for the quantity that we're going to be producing. So the profit per unit is price minus average total cost, but we didn't just produce a single unit, we produced all of the units up to this quantity. So our profit could be shown on the graph as price minus average total cost times the quantity. This shows us the exact amount of the firm's profit. Unfortunately, not all firms earn a profit. In this case, we have a firm that's earning a loss. Let's take a look at how we'd calculate a loss and show it on the graph. Thankfully, the process works the exact same way as calculating a profit. So the first thing we do is we hone in on that quantity where MR equal MC. And then from that point forward, we're going to take a look at price minus average total cost times the quantity, rule number two. We're just going to do it again. So in this case, we start at the bottom. We have price minus average total cost times the quantity. And this area would equal the firm's loss. As you look at this graph, it may not look a whole lot different from the one we did before. How can you tell the difference? Well, in this case, we see that our price is below, or I should say the intersection between marginal cost and marginal revenue. The price is less than the average total cost. If price is less than the average total cost, that means that on average it costs us more to make these items than we're actually selling them for. So if we're taking a loss on each unit and we're producing multiple units, we are in fact producing a total loss overall for the company. Let's look at a third possible scenario. In this case, we'll say that the firm is neither profiting or losing money. So if we had a marginal revenue curve that intersected with a marginal cost curve at the minimum of ATC, then we would find that price equals average total cost. And if price equals average total cost, then price minus average total cost must equal 0. And as you know, anything times 0 is going to equal 0. So if we're not making a profit or a loss per unit, then we must not be making a profit or a loss overall.